Hello everyone, I'm Brianna Lilly Smith from Technology Networks, and today I'm excited to introduce Dr. Chris Whelan, the Director of Neuroscience, Data Science and Digital Health from Janssen Research and Development. They're here to discuss their latest study published in the journal Nature, investigating the effects of common genetic variation on proteins circulating in the blood and how these associations can contribute to disease. This is a first of its kind dataset based on samples from over 54,000 UK biobank volunteer participants. Chris, you've said that to identify the right drug for the right patient at the right time, we must move beyond genomics alone. Can you expand on this point further for our viewers?
Absolutely. Yeah. So I say ever since the completion of the Human Genome Project back in around 2003, modern day genetics has completely transformed our understanding of human diseases. I think the issue is that genetics tells us about the blueprints of those diseases. So when a disease is primarily driven by an anomaly in that blueprint, like a rare disease with a high impact mutation, genetics can completely revolutionize how we treat that disease. But for more complex diseases, the diseases that involve a mix of genetic and environmental factors, genetics only gives us one piece of that puzzle. So proteomics can help us partially capture those environmental components and basically capture the end products of our genetic blueprints. It basically helps us round out the story. It helps us translate the language of our own instruction books.
Thank you. So, the study identified over 14,000 associations between common gene variants and circulating blood proteins, and over 80% of which were previously unknown. Can you talk about any specific associations that were surprising or perhaps exciting for the research team?
There's still so much to parse through from those 14,000 genetic associations that calling out, one or two examples might not do it justice. In the paper, we tried to call out a couple of examples. So as an example, we looked at the complement system. And we found that using those PQTLs, those genetic associations with protein levels, that gene variants in complement factor I have influences on proteins involved in both the classical and the alternative complement pathways. And that just reemphasizes the role of complement factor I as a sort of nexus of the complement system. And at the same time, we found influences of later stage complement genes like vitronectin on earlier stage complement proteins like MASP1 and factor D. So overall, that helps us paint a more nuanced picture of a very complex biological system. But what I'm most excited about, as I sort of said at the beginning, is how we can more systematically parse through those 14,000 associations. I'm looking forward to seeing future papers where we combine the PQTLs with disease-linked single nucleotide polymorphisms to more systematically find new drug targets.
So, you mentioned that future work could include using proteins circulating in the blood to predict whether someone will develop a disease several years before the condition occurs. Can you perhaps talk about how close we are to this becoming a reality?
Definitely. I think that we're relatively close. So there are at least two preprints that have looked into this. They're independent from the study that was just published, but they leverage the same data set. And so in each paper, they show how proteins are highly predictive of 10-year incidences of a range of complex, common, and rare diseases. One of the papers shows that a model that contains as few as 5 proteins can detect illnesses like motor neuron disease or ALS with better accuracy than anything in clinical use. And the improvements from clinical tools for a test like that are substantial, in some cases higher than a 30 or 40% improvement. So I'm not sure how long it will take to transform exciting findings like those to the clinic. It is based on a preprint. It's separate from the paper that was just published, but I'm pretty confident that it's going to happen in the next decade, if not a lot sooner.
That's really interesting. Can you explain to our viewers how this data will be made available to the research community and how you expect it will be utilized?
Yes, so half of this data set is already online for anyone with an approved UK Biobank research account. So that's the first 1,463 proteins, I believe. They're fully available to anyone who has an approved UK Biobank application. The rest of the data set, the full 2,923 proteins, is coming very soon. I don't want to put a particular date on it, but it's coming in the next couple of weeks.
Amazing. Thank you so much for joining me today, Chris.
Happy to. Thanks so much.
To make sure that you never miss a story, subscribe to Breaking Science News, the daily newsletter by Technology Networks. Bye.